Students, welcome to the video tutorial on Standard 9 Geography, Chapter 13, Insolation. I am Jaydeep Mehta. In this chapter, we will be studying about how the Earth is heated by the rays of the Sun.
Insolation is the incoming solar radiation, the radiation given out by the Sun. The Sun radiates heat and energy through electromagnetic waves. These waves, when they reach the Earth, they provide us with heat and energy. Let's look at the Earth atmosphere energy system, how insolation affects the Earth. The Earth's atmosphere and the Earth's surface are driven by the Sun's radiant energy. The energy given out by the Sun operates our atmosphere and also is responsible for various actions in the Earth's surface. If the Sun is believed to release 200 billion parts of total solar radiation, Earth, because of its small size and far distance from the Sun, absorbs only 1 out of the 200 billion parts. You can imagine the amount of heat that the Earth actually receives from the total heat generated by the Sun. This solar energy which reaches the Earth is unevenly distributed on the Earth. All parts of the Earth do not receive the same amount of energy because the Earth is spherical, it is not flat. The Earth atmosphere energy system includes the incoming shortwave radiation that's in the form of ultraviolet light that comes from the Sun, and the outgoing long wave radiation, that is thermal infrared, which is given off by the Earth towards the space.
Let's look at how the Earth and its atmosphere is heated because of Sun's radiant energy. If you look here, you will be able to see that the incoming radiation from the Sun, emitted by the Sun, is in the form of short wave. Now this short wave radiation, when it enters into the atmosphere, some of it is absorbed by the water vapor which is present in the atmosphere, while some, after striking back at the clouds, they are reflected back into space. Some of the radiation, incoming radiation, is also reflected from water bodies and snow on hill slopes. It is expected or estimated that about 51% of the total incoming short wave radiation is absorbed by the Earth's surface. So if 100 units of radiation is received by the Earth, only 51 units are absorbed by the Earth's surface. Rest of it is either reflected back into space or absorbed by components of the atmosphere. Now if the Earth continues to absorb the radiation given out by the Sun, that is insolation, for a very long period of time, it would be heated up to a great extent. But that does not happen so. In nature, the energy of the Earth maintains a balance. During the daytime, the Earth's surface gets heated by the incoming solar radiation, that is insolation. Land gets heated up, even water also gets heated up. This heat is not contained within the Earth for a long period of time. During the night, this heat is given off from the surface of the Earth back into the atmosphere. This process, by which the land gives off the heat absorbed during the day, is called terrestrial radiation, radiation given out by the Earth's surface. This radiation does not allow the Earth to become very hot during the night. This radiation also is the main source of heating of the atmosphere. The atmosphere does not get heated as much by insolation than by terrestrial radiation. So all the 51 units of heat that was absorbed by the Earth during the day is released. Out of these, 64% is believed to be absorbed by water vapor and the clouds which are present in the atmosphere. The carbon dioxide gas also absorbs and does not allow this radiation to leave the Earth's surface. This is how the atmosphere is heated up during night. The atmosphere does not become very cold during the night, as the CO2 and H2O absorbs this terrestrial radiation. This explains how the atmosphere is heated more during the night than during the day. Terrestrial radiation also balances the amount of heat that comes to the earth and leaves back. So next day again insolation happens and terrestrial radiation also occurs. Let's look at how the insolation received by the earth is different in many different ways. If you look at this picture where a torchlight is shining on a surface, you will be able to see that if the light reaches the earth's surface at an angle, it is distributed over a larger area. Whereas if the light falls vertically on the surface, its shadow does not cover a very large area. It is focused and concentrated on very small area. This is what happens when the insolation reaches the earth. As you know, early in the morning when the sun is at the horizon or very close to horizon, the shadow of the substances on the earth or the various topographical features on the earth are longer because the insolation is distributed over a larger area. Whereas when it is noon, when the sun is vertically overhead, the sunlight is focused on a very small area. Only a small area is affected by the insolation. This proves that the amount of insolation's intensity decreases as one moves away from the equator. Places closer to the equator will always have more insolation because the sun rays fall vertically on those places and the heat is confined to a very small area. Whereas when we move away from the equator, the surface area exposed to insolation becomes bigger. The equator receives maximum insolation as the sun rays are perpendicular to the surface. Places away from the equator experience lesser and lesser amount of insolation. Let's look at why there are global variations in the insolation received by the earth in different places. If you see these two pictures, this picture is of morning sun where the sunlight is distributed, insolation is distributed over a larger area, whereas this is a picture of the sun at noon where the insolation is distributed over a smaller area. This is what happens. Earth is a spherical planet, so the incoming solar radiation, when it enters into the earth, it falls vertically on places near the equator and falls at an angle as we move away towards the poles. So radiation passes through a greater length of atmosphere when it is at a lower angle in the sky than when it is overhead. When it is overhead, it passes over lesser areas of the atmosphere. Now, as the insolation passes through greater areas of the Earth's atmosphere, as you can see here, the atmospheric gases, dust and water vapor, they are able to absorb more energy out of the insolation before the insolation reaches the Earth's surface. So areas around place X will have less insolation than areas near place Y, as the sun rays fall at a higher angle, so there is less time for the atmosphere to absorb energy before it reaches the Earth's surface. The second factor which is responsible for varying rates of insolation is continental scale variations. Here you will be able to see a picture of Scandinavian countries of Europe, Norway and Sweden. You will be able to see that the land is darker than the ocean. This happens because land gets heated by conduction, whereas water gets heated by convection. So the specific heat capacity of water is more than land. This photo was taken in the month of June, where the warmer surface are shown with darker color. So here you can say that land is warmer than the sea. Same region, another satellite picture that was taken in January. So you'll be able to see that the warm surfaces are darker compared to the cold surfaces. So the sea here is shown as darker than the land, because in winter land will give off heat very quickly as it is heated by conduction, and the heat remains mostly on the surface of the earth where water is still warmer. The effects of this factor is the temperature of the sea differs less than on land. Land gets heated faster and cooled faster. Land which is present near the sea has moderated temperatures. Those places near the coast, they will not be very hot during the summer nor very cold during the winter. The larger the water body near the land, the greater will be the effect of heating and cooling. Temperatures on land vary more. Summers are very hot, winters are very cold. So the bigger the land mass, the bigger will be the variation of temperature. So in continents like Asia, the temperature changes will be more than in Europe. Land masses which are far away from the coast, they have a more seasonal climate, which means summers are hotter, winters are colder. But places near the coast, they will not have major changes in seasons. They will enjoy approximately or around the same season throughout the year. Another factor which is responsible for unequal amount of insolation is distance from the sea. Here you will be able to see that during the day, sea breezes blow from sea to land, because sea is cooler than land. So the coastal areas near the sea would not be very hot during the day. The insolation will be reduced because of the effect of the sea. Whereas during the night, land cools very fast, whereas the sea remains warm. So breezes blow from land to sea. These are land breezes, and they transfer the heat from land to the sea. As a result, areas next to seas and oceans, they show more moderate temperature characteristics throughout the year. Temperatures are never very high nor very low. Whereas places which are less affected by oceans, places which are very far away from the coast, they will have a greater range between maximum and minimum temperatures, both daily and yearly. Even daily also, days will be very hot, nights will be very cold, and in summers the days will be very hot, and winter the nights would be very cold. So the range between the maximum temperature and minimum temperature goes on increasing as you move away from the coast. Another factor which affects the temperature of a particular place is altitude. If you notice, mountainous areas all over the world, they have lower temperatures than regions which are nearer to the sea level, even when they are at same latitudes. The latitudes of both the places are similar, yet the temperatures are different. The reason is, a place which is located at sea level or close to sea level has a thicker atmosphere over it, whereas a place which is located at a higher altitude has less amount of air above it. So the greater the amount of atmosphere over a place, the more will be the absorption of sun's radiation. So places which are at sea level, they are warmer during the day and not very cold during the night, whereas places at higher altitudes, they are cooler towards in the daytime while they are very cold at night, because the air is thinner and it does not absorb more heat. Another factor responsible for the amount of insolation absorbed by the Earth's surface is albedo. If you look at this picture, this appears to be a forest area, a lot of greenery, dark colors, whereas this place which is shown is covered with snow, probably light in color. So albedo is the reflectivity of the Earth's surface, how good the Earth's surface can reflect the incoming solar radiation. Darker colors have a lower albedo, so it can absorb more incoming solar radiation than lighter colors. So in both the pictures you will be able to see The snow-covered mountains, they have the maximum albedo. The forest has the least because it is dark in color. So temperatures in the areas of mountains where there is a lot of snow will always be lesser than places which have darker surfaces. Another factor which is responsible for the varying rate of insolation is the aspect of slope. If you look at this picture, it's of a hill which is sloping in two different directions. It has a north facing slope that's facing towards the poles and the south facing slopes which is facing towards the equator. You will be able to see that north facing slopes are snow covered, there is some snow, whereas there is no snow on the south facing slope. This is because in this particular region, the southern slopes of the mountain face the sun's rays. So even if the sun's rays fall at an angle over the southern slopes, those regions are warmer than the places which are on the shady side of the mountain. So they are cooler. A very good example of this are the Himalayas, where the southern slopes face towards the equator. So most of the hill stations are also located on the southern slopes, whereas the north facing slopes of the Himalayas, they face towards the poles where they get very less amount of insolation. So they remain cold throughout the year. So that is aspect of slope. As you know that the earth is spherical in shape, so the sun rays cover a small area near the equator, whereas they fall at a lower angle as we move away towards the poles. The polar regions get very slanting rays of the sun. So let's see what happens because of unequal radiation on a sphere. Near the equator, because insolation is greater than the terrestrial radiation that is given out, these areas are very warm. In the mid latitudes, it can be assumed that the amount of insolation is equal to the amount of terrestrial radiation. So temperatures are moderated here. Polar regions, the insolation is less than the terrestrial radiation. So the heat given out is more than the heat that is received by the Earth's surface. What does this lead to? This leads to the generation of winds on the Earth's surface. As you can see here, there is a heat surplus in areas between the equator and 40° north and south, whereas there is a deficit of heat in the polar region. So as I told you before, at 40° north and south, the insolation is equal to the terrestrial radiation throughout the year. Beyond 40° north and south, there is a deficit, whereas between equator and 40° north and south, there is a surplus. If this heat did not move, the poles would become colder and colder, while the equator would become warmer and warmer. But that does not happen because the transfer of heat is done by ocean currents. We have already seen how currents move from equator towards the poles and poles towards the equator. Winds that blow, they carry the warm air towards the poles and bring the cold air towards the equator. So they help in keeping the temperatures moderate or equable throughout the year. Because of varying amount of insolation, the temperatures of the earth are maintained in many ways, which is known as the greenhouse effect. Let's look at what is greenhouse effect. When the sunlight comes towards the earth, it is reflected back by the earth's surface and it heats up the atmosphere. But because of human activities like number of vehicles, industries and other activities, we are giving out more and more gases which act as greenhouse gases, and they absorb more heat given off by the terrestrial radiation of the earth. As a result, the earth's temperature, that is the atmosphere's temperature, goes on increasing. This increases global temperature, we already know that, and because of greenhouse effect, the problem that the whole world is facing is global warming. It's not that the global warming process is a recent occurrence. Global warming has been happening since billions of years, which has kept the earth in a balanced state. But because we are releasing more and more greenhouse gases like carbon dioxide through smoke of vehicles and factories, it is affecting the respiration by human beings. It is released, and when plant and animals remains decomposed, they release carbon dioxide. When matter is broken down chemically, then also carbon dioxide is released. Through volcanic eruptions, more and more carbon dioxide is released into the atmosphere. When we burn coal and petroleum, that is fossil fuels, we give out a lot of carbon dioxide. Smoke from factories and vehicles, that also generates a lot of carbon dioxide. Carbon dioxide is the main greenhouse gas. It does not allow the terrestrial radiation to leave the earth. It traps more and more of that heat released by the earth, which results in more greenhouse effect. Deforestation is another way. By cutting trees, we are not allowing the carbon dioxide to be absorbed by plants, so more of that is released in the air. There is a huge concern over global warming, the way it has been experienced by people all over the world. The effects of global warming are far-reaching. We know that temperatures of the earth are increasing at a very fast rate. Some measures that can be taken or which are necessary to be taken is use of alternative energy resources. We must focus on generating energy because that is required world over. Alternative sources like solar, wind, tidal and others. We must reduce deforestation because plants take in carbon dioxide when they do photosynthesis, so they can help in reducing carbon dioxide levels in the atmosphere. We should plant more and more trees, that is afforestation. We need to use alternative material for daily uses. Instead of using materials which pollute the environment, we must use products which do not pollute the environment. Reduce chemical fertilizer usage in farming. That is one way in which we can solve the problem of global warming. Thanks for watching. The next tutorial will be on chapter 14, atmospheric pressure and winds. This is Jaideep Mehta signing off. Thanks.